Hello everyone, welcome to Pepcoding. So in this video we are going to discuss the question maximum path sum in between two leaves of binary tree. So what is given in the question? We'll be given a binary tree and we have to find the maximum path sum, and that maximum path sum should be in between two leaves of binary tree. Okay, so let us discuss the question. Let's move to our binary tree. So this is our binary tree. Suppose we'll be given a binary tree and we have to find the maximum path sum, and that path sum will be in between two leaves of a binary tree. So first consider what are the leaves in binary tree. So these are the leaves of a binary tree and we have to find the maximum path sum between any two leaves. So let us consider these two leaves, that is -3 and 1. So if we want to have the sum between these two leaves, then we will have, so our path will be having all these nodes, that is -3, 2, -8, 5 and 1. Suppose we have taken these two leaves, 6 and 3, then our path will have 6, -8, 5, -12, 6 and 3. Okay. Suppose we have taken two leaves as 4 and 10, then our path will have 4, 2, -2 and 10. See, if you are thinking that we can also have the path like 2 like this, okay, then you are thinking wrong. Why? Because we have to obtain the path sum between two leaves. 2 is not a leaf. 2 is not a leaf, and the restriction is that should be between two leaves. So we can't consider this path. Okay, so let's remove this path. So if we are taking into consideration this thing in between two leaves, then there can be three cases. The first case can be both the leaves are present in the left subtree, which is this case, and both the leaves can be present at right subtree, which can be this case, and it can also be the case that one leaf is present in left subtree and the other leaf is present in right subtree. Okay, so what will be our approach for this? See, we'll maintain a static variable that will be containing our maximum leaf to leaf sum. Okay, and what our fate will be? Our fate will be our left subtree will return the maximum path sum from leaf to this till this node. This our when we'll call our left subtree, then our left subtree will return the maximum path sum from any leaf to this till this node, and that sum will be maximum. There can be many paths, okay, but this will return the maximum path sum. And when we'll call our right subtree, then our right subtree will return the maximum path sum from leaf to node, from leaf to this node. Okay, and also we have to consider the point then that apart from returning, this will be maintaining maximum leaf to leaf, and that will be containing what? That will be containing the maximum path sum from leaf to leaf. Okay, so there are two cases. When we'll call our left subtree, then it will be containing the maximum path sum from leaf to leaf. This is maintaining in the static variable, and what it will be returning? It will be returning the maximum leaf to node. So that will be left. So it will be returning left maximum leaf to node, and this will be returning right maximum leaf to node. And static variable will be maintaining what? Static variable will be maintaining maximum path sum from leaf to leaf. Okay, so these things we are returning, and our answer is maintained in this static variable. Okay, so ultimately our answer is maintained in this static variable. So let us implement this thing in our code. So this is our max path sum function. So our very first step is we will be maintaining a static variable, and that will be containing maximum leaf to leaf sum, and initially it will be minimum value. Okay, and our next step is, this is our function. First we will check the condition. If root equals to null, then return minimum value. Okay, and the next step is we'll call a function. We'll call the function. We'll create later on maximum path sum. We'll pass this root value, and what this see, we are not returning any answer, we are maintaining our answer in this static variable, so we will return this answer, maximum leaf to leaf. Okay, so let's create the function which we have called. So this is maximum path sum underscore. So our base condition will be, there will be two base conditions. If root equals to null, then return minimum value. If root dot left equals to null, and root dot right equals to null, then return value of root. So root dot value. So next what we'll do, we'll call to left subtree, and that left subtree will return me what? That left subtree will return me maximum of node to leaf sum, that is node to leaf maximum sum from left subtree. Okay, so maximum path sum root dot left this will be from the right side. See, if you are not getting the importance of these things, then no need to worry, we will be discussing these things in our dry run, then you will understand more clearly. And our condition will be root, if root dot right not equals to null, and root dot left not equals to null, then we'll be maintaining our static variable max. We'll be maintaining our answer in this static variable maximum leaf to leaf. Compare math dot max this will be right. And then we have to return so we have discussed this thing while we were discussing our faith that we'll be calling to left subtree and right subtree. Okay, and left subtree was returning me what? Was returning me maximum sum from node to leaf from left subtree, and our right subtree call was returning me maximum sum from leaf to node from right subtree. Okay, and then we have checked the condition. If root right of root is not equals to null and left of root is also not equals to null, then we are maintaining our answer in maximum leaf to leaf, means it is having both the leaves. So at last we are returning something, and that is maximum of left and maximum of left and right plus value of root. So let us do the try run. I hope it is visible to you. See, we will be doing the dry run for this half, otherwise it will take a lot of time, and you will understand the whole things within this tree only. Okay, so let us remove these things. So initially root will be -12, and this will be first condition, second condition, third call, fourth call, fifth condition, sixth we are returning. Okay, so these statements we have numbered. This will be first condition will be checked, which is false. Second is also false, so we'll call for third left subtree. Okay, here also all the three conditions will get checked. We'll move to this side. All the three condition will move to this side. At this second condition will become true. Root dot left equals to null and root dot right equals to null. So return root dot value, return 2, and that 2 will get attached to left of it, and then we'll this is attached to left, then we'll make call for right subtree, and when we are calling for right subtree, we'll check the first condition and second condition. So second condition will become true, and we'll return root dot value, that is 6, and this 6 will get attached to right of it. Okay, so now our next step is we'll check this fifth statement, and this fifth statement is true because right of root is also true. Right of root is also not equals to null, and left of root is also not equals to null. So we will maintain our answer in max. So our maximum will be having initially maximum is minimum value, so that will be minus infinity suppose, and out of this minus infinity and left plus right plus root dot value, that is 6 plus 2 plus 6 plus 2 plus minus 8, so that will be 0. So minus infinity comma 0, maximum out of these are 0, so max will have 0. Now it's time for sixth statement. Now we'll return maximum of left comma right, that will be 6 plus minus 8. So that was minus 8. Okay. So that was minus 8. So 6 minus 8, that will be minus 2. So we'll return minus 2 and this minus 2 will get attached to left. Then we'll make call for right subtree. Then right subtree will check the condition first and second. So second will become true. This will return root dot value. That value will be 1 and 1 will get attached to right of it. Then we'll check fifth. We'll execute fifth statement. We'll check the condition root dot right not equals to null, root dot left not equals to null. Then we'll maintain our maximum. So our maximum will have maximum of, earlier max was 0. So it was 0. It was 0. Now we'll compare with left plus right plus root dot value. So that will be minus 2 plus 1 plus 5. So that will be 4. So our max will have 4. Okay. So now we'll execute the sixth statement. This sixth statement will return maximum of left and right, that will be 1. 1 plus root dot value, that will be 6. We'll return 6. 6 will get attached to left. Now we'll make call for right subtree. We'll call for right subtree. Then this will check first and second condition. Now call for left. So this will return 3 and this 3 will get attached to L, that is left. Okay. Now we'll call for right. Calling for right, we'll check the first condition and second condition. See, for second condition, root dot left equals to null. This is true. And root dot right equals to null. So this is false, because right is not equals to null. But ultimately this condition will become false because this is AND. So we'll not get into this if condition. So we'll move out of this if condition and we'll execute third statement. Call for left. And then we'll check first statement. So this will become true because root equals to null. So this will return the minimum value, that is infinity. So this will get attached to left. Okay. Now we'll call for right. So calling for right, first statement will get checked. Root equals to null, false. Second will get checked, yes. Root dot left equals to null, right equals to null. See, we have removed these things. For now our tree is this much only. So this will become true. This will return root dot value, that is 2. So this root dot value will get attached to right. Now we'll execute fifth. So root dot right not equals to null, root dot left not equals to null. So this condition is root dot right not equals to null. This condition is false because, sorry, this is true. See, we have checked right first. So root dot right not equals to null, true. Root dot left not equals to null, this is left. So this is false. So ultimately this will become false. So we'll not be maintaining max this time. So we'll directly come into this return statement. Okay. So come into this return statement. So this will return me what? This will return me. So from here, this will return me maximum of left and right, that is right, 2 plus root dot value, that is 11. So this will return 11. This 11 will get attached to right. Now again, fifth statement will get checked. Root dot right not equals to null, root dot left not equals to null, true. Then we will be maintaining max. Till now max is 4. So now we will compare with 4. Okay. Comparing with 4, left is containing 3, right is containing 11 plus root dot value, that is 11 plus 3 plus 6, that is 20. So max is containing 4 comma 20, that is maximum. So 20. 4 comma 20. So this will contain 20. Okay. Now we will come into sixth statement. This will return maximum of left and right, that is 11 plus 6, that is 17. So this will return 17. and this 17 will get attached to right. Now we will execute fifth statement. Root dot right not equals to null, root dot left not equals to null. True. We'll be maintaining maximum over here also. So maximum of max, that was 20, comma left plus right plus root, that is 17 plus 6 minus 12. So that will be 17 plus 6 will be 23. 23 minus 12, that will be 11. So maximum will be 20 comma 11. So this will contain 20 only. Now we will return what? So till now maximum is 20. We will return maximum of left and right 17 minus 12, that is 5. So we will return 5 from here. Okay, and see, we are not maintaining answer while returning. We are maintaining answer in this static variable max path sum. So from where we have called? We have called from this function our max path sum, and after executing this function we have returned the value max leave to leave because we have maintained our answer in this static variable. Okay, so now let us run the code. Okay, so there is some error. Variable right node to leave. Okay, so this will be right. So accepted, submitted. So all the test cases are passed. So I hope you have understood the question and the solution also. So that's the end of our video. We'll be meeting in another video with another question. Thank you for watching.